So write down the heading. Today already we have learned like normal, okay? So today we are going to study tension in string. This topic we will understand in depth. What is the meaning of tension in a string? Write down this heading. Now see. Just write. Tension in a string means, for example, if you take any wire, clear? If it is any wire, this wire is made up of some material, clear? And every material has different atoms and molecules, clear? And when you apply a force on this wire like this, clear? Then what will happen? The atom inside this, there is an atom like this, clear? Atom has their fixed position, mean position, clear? So once you extend like this, so the atoms also extend, clear? Atom also have some separation. This is the stable condition, clear? This is the stable condition where atom want. This is stable. But once you apply a force, these molecules or atom, you can say this will extend like this in this direction. Clear? Then when you apply a force, this molecule will extend in this direction. Then this adjacent molecule will apply a force on this molecule in this direction. Similarly, like this. Clear? If you look at single molecule, then if this molecule is going in the right direction, then the surrounding molecule will not allow this. It will apply a force, internal force, small f. Similarly, if this molecule is going in this direction, this molecule will apply a internal force in this direction. This internal force is known as tension. Clear? Because when you extend now, when we are applying like this, clear? After removing the applied force, the string comes back to its original condition. Rubber band, you know rubber band? When you remove the applied force, rubber band comes to its original position. Why? Because of this internal force, or here we are saying this internal force is tension. Clear? Understood? The molecule will extend, and no molecule wanted to be in a unstable condition. They want to be a stable condition. That is why they will go in this direction. They will apply force on adjacent molecule like this. Clear? So when you are not applying any force, for example, you are taking a string and you are not applying any external force, then what will happen? Like this. If no force, clear? No force, then all the molecules will be in the stable state. They will not apply any force on each other because they are not extant. Clear? So when a string is tight, then only tension will come. Clear? So you can write here, and it is electromagnetic force. Electromagnetic means between the electrons, simply. Clear? Understood?
Tension is electrostatic force, sir.
Electromagnetic force. Electromagnetic. Because charge particle, inside atom is charge particle. Clear? Understood? In chemistry language, if you want to understand like this, if two atoms like Cl, NaCl, clear? When NaCl is Na plus Cl negative, then plus will attract negative. Clear? When you increase the separation, then partial positive, partial negative, like that. Clear? Molecule will become polarized. There is a interaction between the charges, that is electromagnetic force. Similar things are happening here if you go in depth. Chemistry. Clear? So you can write here, but you should not go in such depth. You should understand the meaning of tension. That is only. Clear? So right here, write the definition of tension. Tension is an electromagnetic electromagnetic force applied by applied by atom on neighboring atom neighboring neighboring atom to avoid separation between them. Clear?
Okay.
Every molecule wanted to be in a stable state, means minimum energy. Clear? Clear? So here tension will be what? Here tension equal to force. Clear?
Okay.
This is what? No force means this is, you can write here, this is loose string, loose string or slag string. Slag means we are not applying any force. It is in a loose condition. It means tension is zero. So tension will be there only when there is a applied force. If there is no applied force, it is clear, zero. Clear? So write down next. Have you written this?
Yes, sir.
After this, write down value of tension is self-adjusting. Clear? Is self-adjusting. Clear?
Okay, sir.
Depending on question. As per the question, it will change. Clear?
Yes, sir.
Depending on question. Now, tension is a force. Clear? Tension is an electromagnetic force. 1 minute. Wait, sorry for disturbance. So tension is a force. So it has some direction also. Clear? We will understand how to find the magnitude and how to find the direction. Clear?
Okay.
So write down direction. Direction of tension. Direction of tension is along a string. Along a string. And has a tendency and has a tendency to attract the body. Clear?
Well,
For example, like this. If you take this example, this is a string. Clear? Second case, if you attach any weight like this. Clear? Now, if I ask you, what is the tension here? Zero. Clear? But here, and this is the cross section area, or at this end we are attaching a weight at the end of the wire. Then what will happen? Because of this mass, gravity will pull this like this, mg. It is going
The
down.
weight of the weight of the body is equal to tangible.
Yeah. So my question is, what is the direction of tension? Direction of tension is along a string and has a tendency to attract the body. Now, in which direction the tension will attract this body? Up now.
Downward.
Attract the body. Direction
Sir,
of
along
tension
the
is
string.
along a string. Along means parallel to string, and has a tendency to attract the body. Attract the body. Body means this. In which direction?
Oh,
Because you just tell me when you apply this mass, then molecule will extend here. Molecule will extend. Clear like this. Then in which direction tension will be? Opposite now. Because of this weight,
oh,
it is going stretch in the vertical downward direction. The tension will be opposite like this. Or you should understand like this: tension has a tendency to attract the body. For in which direction this tension will attract this mass? Up now, when it is like this. Clear? This is a
okay.
wire on which some mass is attached like this. Clear? Tension will be along this
Okay.
wire and has a tendency, direction of tension will be, has a tendency to attract the body. This body, it is going down. Clear? Then tension will attract this body. How it will attract? Like this now. When the direction of tension will be like this. Clear?
Sir, sir, if the mass becomes more and more increasing,
Ha,
then at
that
some
is,
point of
then tension is self-adjusting. I'm telling you, tension is self-adjusting depending on question. If you increase the mass, then tension will increase.
sir, at some point of time, the mass, that weight will be more than the tension. No, sir. At that time, the string will
Tension, then
share
when
the
the
force.
mass is more, for example, if you are putting a 2 kg mass, 3 kg mass, then tension will increase automatically. Clear?
Oh, okay.
Now, second question, if I ask you one more thing, if I ask one more question to you like this, this is the pulley, okay? And if I attach any mass like this, you please tell me tension force, okay?
Oh,
See what I am doing. There is one string that is passing to a pulley like this, and it is attaching these two blocks. Clear? Understood?
yes, sir.
Same string is attaching two blocks. If a string is same, then tension will be same only. Clear? Because string is not changing. If a string will change, then tension will also change. Now you please tell me in which direction, this block is having the mass m1, for example, it is m2. Clear? In
Okay.
which this string will attract this mass in which direction? Like this now.
Yes, sir.
And here this portion of the string, it will attract this mass in which direction? Like this.
Uh,
Up.
okay.
Clear? Or you can say along a string and has a tendency to attract the body. Otherwise, this body is going down. Then in which direction it will attract this body? Up now.
Okay.
Clear?
Yes, sir.
Understood?
Yes, sir.
Or one more thing I will tell. Here, every atom has electron. Clear? Electron of this string, let us suppose here. An electron of this mass is here. Then electron of the block M2 will apply the repulsion force in which direction? Up on this string. That is why tension is up. Clear?
Yeah, okay.
And the electron of the string will apply the force in which direction? Down. Clear?
Okay.
So block is applying the tension in downward direction, you can say, and string is applying tension up. Electron repulsion, you can say like that also.
Okay.
Because they are that much close, So there is a repulsion force. You can understand. You can understand that two ways. One is direction of tension is along a string has a tendency to attract the body. Second, the direction of tension, like this repulsion theory. In which direction it will pull this block, like this. Pulling nature. You can say like that also. In which direction this it will pull, like
Okay.
this. Or repulsion theory. Clear?
Yes.
Understood? So write
Yes.
some properties of tension, right? Or properties of properties properties of tension. Under this, write down. First, tension is present at each and every point of the string. At each and every point of the string. Clear? Sixth point.
Yes. Yes.
Write down. Next point. Value of tension this is experiment. Okay, value of tension is same. You should learn this. Okay, value of tension is same if a string is massless. Massless. Understood? Massless means very negligible mass. If note if if uh, if a mass of a string, so you can write here value of tension is same if a string is massless. Clear? If a mass of
Okay,
a
sir.
string is not given, you can write if a mass of a string is not given then it is considered to be massless. Clear?
Okay.
Massless means very light and inexpandable string. Massless means very light string. Clear? Third point, right here. Tension tension on both sides of the pulley is same. Full stop. Please, if pulley is massless or smooth, very important. Pulley is massless or smooth. Clear?
Ah, yes, sir.
Have you written this?
Sir, writing the last point.
All right. Now write what is pulley. This word you will listen in this entire chapter. Write down. Pulley means circular body, circular body, free to rotate, circular body, free to rotate, circular body, free to rotate. Clear? Any circular
Yes,
body,
sir.
disc-like shape. Clear? If, write down, if shape of pulley is not given, if shape is not given, if shape is not given, then pulley is a disc. What is the shape then? Always take disc. Clear?
Okay.
Now we will understand with some examples
Yes,
like
1 minute,
this.
sir.
Okay, right. Take your time. Clear?
Okay.
If I switch on this cooler and tell me my voice is audible or not properly, tell me.
Yes, sir.
Audible?
Yes, sir.
Disturbance are coming or it is audible?
It's audible only, sir. No disturbance.
Audible now?
Yes, sir.
Like I have on like this cooler. Is it like voice of cooler is coming to you?
No, sir.
It's not coming. Are you
No, sir.
sure? Not coming? Can I open?
Not coming, sir. It's okay, sir.
Okay. Then we will open. Clear. Now
Yes,
look at here. Clear. Look at here. This example. Clear. If I take a pulley, pulley means circular disc. And if I take one string like this, one string. Clear. And this is one more string. And two blocks I have attached. One block is here. One block is here. That's true.
yes, sir.
This block is having the mass head. This block is having the mass head. Both I have taken mm. So if I ask, what is the direction of tension force? If I ask, draw the tension force, how will you draw? First condition, if nothing is given, clear? This string, both the blocks are connected by the same string. Understood?
Okay, sir.
Then tension here will be same only when the pulley is massless. This pulley is, if nothing is given, what is the mass of this pulley? Always take massless pulley. This concept, okay, massless. What? Massless. This pulley is massless, means it has very negligible mass or smooth.
Oh,
Massless or smooth. Understood?
oh, yes, sir.
Now, if I ask you, if this condition is valid, then the two blocks are connected by the same string. Then here tension T, here tension T. Clear?
Okay, sir.
This is the starting end. From here, this is the ending. And this is the length of the string on the pulley. Clear?
Okay.
And one more thing, if you take here, direction of tension will be like this. Up. Why it is up? Because gravity is applying the force on this mass downward direction. Then String has nature. The direction of tension is what? It is along the string and it is always attracting the body or pulling nature. Clear?
Okay.
Understood?
Yes, sir.
If I ask like, what is the tension here? Here, what is the tension? It will not be same. Here, this string is different. This string is different. Clear?
Okay,
Understood?
sir. Yes, sir.
This string is different. Here, tension is like this. T dash. In which direction this string will apply the tension force so that this pulley will be balanced? Up now.
Yes, sir.
You keep your hand. You keep your hand on the pulley like this and see where the string. The string is up. Clear? Then direction of tension will be up. Clear? Understood?
Okay. Yes, sir.
When I'm going to teach like what like system, then it has more clarity. If I ask like if you if you keep your hand means if you take this pulley as a system you understand?
Yes, sir.
Okay, then it is more clear. Okay, just see here. If you take this pulley as a system, now put your hand on this pulley on the system. Then in which direction the string is up, tension will be up. If you here if you look at like this, here one string is like this, one string is like this. Here, then if
Okay.
you take this pulley as a system and if you draw all the forces, means all the tension force, then here tension will be like this. It will be same TT, but direction will be different.
Why, sir?
Why? Remember, here I have taken massless pulley as my system. Then put your
Okay,
hand
sir.
like this on pulley. One string is this, one string is down, two string is down. Clear? Direction of tension is along the string.
Okay,
Clear?
sir.
So you please tell me, this is what? Here, string is up. Here up. That's why it is up direction. Here string is down like this. It is down. If you take this block as a system and put your hand like this on this block, just keep it like this. Then a string for this block is like this. So direction of tension will be up because string is up. Attracting nature. Attracting nature. Always see the system. System means what I will explain later. First, understand this.
Okay, sir.
Clear? If you take different system, then direction of tension will be different. Clear?
Yes,
If I
sir.
will not take system, then you will be confused totally. That is why we are taking system.
Okay.
Understood?
Yes,
If
sir.
I ask one more question to you, I think if I ask you, please try this, okay? Wait. You give me the answer. Later you have more clarity once I start system. Clear?
Okay.
For the time being, just understand direction of tension is along the string and it is always attracting the body. Now this string, see this string, this portion of the string, this string will attract this pulley like this. Clear?
Sir? Yes, sir.
This string will attract this two string. It will attract the pulley in this direction.
Yes,
And
sir.
the top wire, top string, it will attract this like this. That is why if you take this is a system, then direction of tension will be like this. Just from this example, it has more clarity. For example, if we are take two blocks like this, here Dinesh, and
Yes,
this
sir.
is the string. Understood?
Yes, sir.
And if I ask, this is starting end, it is end. Here length of the string on the pulley. This much only, start or end. Could you please tell me, if this is your system, M1, it is M. If this is your system, what is the direction of tension force? If
Sir,
this is
from
M1, in which direction a string will attract this system? M1.
this direction.
Very good, very good. Great. Absolutely correct. If I take this block as a system, in which direction this string will attract this block?
Sir, this direction.
There is only one string, clear? And here T, here T. Why? Because pulley is massless. Then, and both the blocks are connected by the same string, clear? Then tension will remain same.
Okay.
Next question, if I ask, if you take this pulley as your system, then both the string will attract this pulley in which direction?
Sir, one is
Both the,
direction.
very good, very good, very good. That is why direction of tension will be like this. Here also T, here T, here also T, like this. T.
Okay.
Why TT everywhere? Because string is massless. String is massless and pulley is massless. If by mistake, this concept, if pulley is not smooth, means rough, or we can say it has some mass, then the mass of the pulley will affect the tension. Because pulley is massless, then it has very, very less effect on tension. But if it is having the mass, then it will affect the tension. There TT, it will not be TT, okay? T1, T2. Understood?
Okay, sir.
Now, after this, I will start spring force. Write down the heading. Basic. First, we will learn the basic. I am teaching you basic. Basic tension force we have learned, gravitation we have learned, normal we have learned. After knowing all the forces, their direction, what is the meaning of that, then we will start the force and laws of motion chapter. Then it has more easy. Clear?
Oh,
After
okay.
this, write down spring force. Spring force. Spring force. What is the difference between a string and spring? First question. If you look at carefully, like this way, this is string, and if you make a coiled structure of string, this is spring, and this is string. Meaning of tension is same here. We are saying tension here. We will say spring force. Clear?
Okay.
But the meaning is same. Definition is same. It has same nature. Okay, like tension, attracting in nature. Like it is also an electromagnetic force. Clear? For example, let us understand. Spring is nothing. Spring force is nothing. It is just like a tension. You can write here tension in spring. Similar to that. It is just like a tension in spring. Spring force is nothing. It is just like a tension. Tension in spring. Clear?
Okay.
For example, one length of the string is like this. This is the natural length. What? Allo. Allo is what? Natural length.
Length of
Natural length of the natural length of the string. Understood?
okay.
And if you apply if you apply, for example, if you apply a force, this string will extend like this. If you apply a force on this external force like this, then the length of the string will be what? Let us suppose L. Clear?
Yes.
Then one term in string is what is important. How much change in length? X will be L minus L. So X is what? Extension. Extension. Or extension. Clear?
Okay.
Extension when we will say when L is more than L naught. Clear? When L is more than L naught, we say extension or elongation. Clear?
Okay.
Any doubt?
No, sir.
If I apply the force like this, a string is there. If I apply a force because of this, it will be like this. If I apply a force like this, then you can check. Initial length is L, final length is L. Then how much? L minus L. He will say this is compression because final length L is less than L. This is acts as what? Compression. Understood? Compression. Compression means final length is less than the initial length, natural length. Compression. Compression. Clear? Then
Okay.
same thing. When we are now concept is when you are taking any spring, you are applying a force. When you are applying a force, then extension is directly proportional to this. More the extension, more is the spring force, FSP.
Okay.
If you apply a force like this, the spring force will be back, up, like tension. Clear? Understood? X is proportional to, clear? Then if you remove this proportionality sign, FSP will be what? Minus K X. Very important. Now what is this minus? Minus means direction. Direction of direction of tension, or you can say here spring force. Direction of FSP is opposite to X. Opposite to X means extension, displacement. Clear? What is K? K is spring constant
Constant.
because it belongs to string, so we get spring constant or force constant, force with force constant or stiffness. I'm writing here clear. Stiffness. Meaning is same. What is the meaning of this? Just see, look at here. If extension is there, extension means backside of it. See, spring constant, force constant, or stiffness constant. Meaning is
1 minute.
here. Now properties
Ah,
later we will understand. First you will understand the direction of tension, this spring force. Very easy. If you look at this formula, FSP is minus K into X. Meaning is what? X will be L minus LO. Final minus initial. Clear? It should not be initial minus final. Final minus initial. If a spring is there, if you apply the force and the length of the spring increase, then X will be positive. Clear? If X is positive means FSP will be, if you check the formula, it will be negative. Negative means like this, direction will be like this. Clear? Opposite.
Okay.
One more like I will discuss with you. If the string is like this is spring. If you apply a force, it compress. Then in which direction spring will be? X will be here. If you apply a force, X will be negative. Because L is less than L. X is negative. X negative means negative, negative, positive. FSP will be positive. Positive means right. Spring force will be like this. Clear?
Yes,
Here,
sir.
if you look at here, in which direction X will be? X direction will be like this. Here, FSP in the right, then X will be left. Like this. Negative. X is vector. Clear? Vector. Displacement or extension. Positive
Sir, then
means
in
right. Because it's a force. Clear? X is nothing, it's a displacement. How much you are displacing from mean position. Mean position means this is the mean position. Here you are not applying any force. From this position, how much body displays? Like this. One more example. Just give me 1 minute. I think slide finish. I will add. Tomorrow I will continue. Clear? No need to worry. Properties.
okay, sir.
Actually today I came from a long distance, so but still I want to take class because lot of holidays we have taken, so I don't want to miss. For example, what I am speaking, like this. If this end is fixed, a wall is there, rigid wall, and one spring is like this. If no force you are applying, then a spring force is zero. Half SP zero because there is no extension in spring. Minus K extension is zero. It is in natural length L. But when you apply a force, this is when a spring force is zero. It means this is mean position. Clear? This is what? Mean position, fixed position, balancing position. No spring force means simply it is mean position. Net force is zero. Clear? But once you apply a force, the string length will increase when you apply a force like this. So when you apply a force, in which direction from the mean position, how much body displays? This much only. X. Clear? And if you look at this, X will be what? L minus this total length minus this LO. Clear?
Yes, sir.
Then FSP, if X is positive, K never be negative. Okay, negative multiply positive. What you will get? FSP will be negative only. Negative means like this. FSP. Understood? Or you can understand one more example like this. A spring is like this. No force. Clear? When you apply a force on this, let us suppose this length is L, natural length. If you apply a force, then it will be like this. When you apply external force, this length will be how much? L. Then if somebody asks how much body displays, how much? Body displays like this, you displace like this. How much? This X, like this. Compress. This much X you compress, then this X will be what? L minus L, and it is coming out to be negative. That is why I have drawn negative, negative. That is I have drawn like this, left. And when X is negative, the spring force will be formula minus multiply X is negative. So it will come out to be positive. Positive means in which direction spring force will be like this. Understood?
Okay, sir.
X simply means displacement from mean position. If you displace in the
Oh,
right, compression will a spring force will be in the left. If you displace in the left, a spring force will be in the right. Clear this concept? Tomorrow
yes,
lecture I
sir.
will discuss what are the properties of spring force. Clear? What are the properties? After this, I will discuss nuclear force. Very, very basic only. Nuclear force, you should not learn in that basic. You should understand what is nuclear force, what is weak force. You are not going to do PhD. First of all, I'm clearing one thing. You are not going to do PhD. You should learn the concept. Clear? Apply. Concept and application. Concept and application. You should learn the physics like that. Clear?
Okay, sir.
Whatever
Yes, sir.
application is possible, I will give some example also. Once I complete this, then I will start for first law of motion, second law of motion, then inertial force, inertial frame, and non-inertial frame, pseudo force. Clear? Then after clearing those
Okay,
things, I will move to the basic like sliding friction part. Objective question. Then this chapter is finished. Then circular motion start later. Clear?
sir,
So I will
will
stop.
there be tomorrow?
What?
Will there be class tomorrow, sir?
Yeah, class maybe in the because I don't know because too much tired I am today. If I wake up early, then I will take class. Otherwise, I will take in the evening. No need to worry.
Okay, sir.
Clear? Tomorrow I will take in the evening. Okay,
Okay, sir.
Danish, take care of yourself. I'm really sorry for like this much problem happened in between that.
No problem, sir.
No need to worry. Okay, just learn like a warrior. Work hard.
Okay,
Keep it like that. Okay. So thank you so
okay,
much,
sir.
Dinesh, for listening
Thank you,
me.
sir.
Thank you. Thank you so much.
Thank you. Bye.
Bye.